Okay, so the next part is dealing with quadrilaterals. You're going to see this in Math 2 like crazy. Okay, we actually have a hierarchy of quadrilaterals. A quadrilateral is nothing but a four-sided figure. Okay, four-sided polygon. And it can be broken down into three different categories. Okay, you see this first category here goes out to a parallelogram. Then the parallelogram can be both a square and a rhombus, a rectangle and a rhombus, which then both go down to a square. The quadrilateral going down here, the kite is kind of its own separate category. And then the last category is the trapezoid, where it goes to the right trapezoid or the isosceles trapezoid. When you're being asked anything about these, like does a square have properties of a parallelogram, or does a trapezoid have properties of a right trapezoid, you always want to read this chart bottom up. So in other words, if I look at the square, I can say the square is also a rhombus, a rectangle, and a parallelogram. See, I'm going up. Why? Well, a square has four equal sides. That's a rhombus. It's got four right angles. That's a rectangle. And that's got two pairs of opposite sides that are parallel. That's a parallelogram. You put all three of those together, you get a square. So when you are asked properties, you want to read these upward. I told you about things right here. I gave you this chart about the properties of the parallelogram, the rectangle, the square, the rhombus, the trapezoid, and the kite. I'm sure you can read this. I'm not going to read every one of them. But know this, okay? Know this for our class because you're going to be doing a little bit work with it with distance and slope. But it's also going to deal with classifying quadrilaterals. And I'm telling you, this is all Math 2. So know this. I also decided just for fun to show you the hierarchy of, not the hierarchy, the what other polygons are called. You know, your three-sided is a triangle, five-sided is a pentagon, eight-sided is an octagon. So I just went up to 12. 10 is a decagon, 12 is a dodecagon. I think 20 is an icosagon. 11, I think, is a duodecagon. But you don't have to get that involved. So there's just some more names. Then what I did is we have a problem on distance, midpoint, how to write that problem out, how to classify triangles. And then we've got some harder problems here where it wants you, say, to determine the slope of each side. Remember your slope formula, you can either count it or look at it, or remember that your slope formula is y2 minus y1 over x2 minus x1, and you can identify all the points on here and actually figure out the slopes. So you would actually have to figure out the slope of each side. So you'd go the slope of zx, then you would do zy, the bottom, and then xy, the other side. Zy should be easy because it's horizontal. Zy right here, we all know the slope of a horizontal is always, and then I would pause and ask you, and then all of you would very intelligently say 0, Mr. LaChance. Anything horizontal has a slope of 0. Remember, anything vertical has a slope of undefined. So you could probably find those slopes pretty easily now that I gave you a little help with that. Determine the length of each side. That means they want the distance. So you're going to do the distance formula for zx, zy, and xy. Then they want the midpoint of each side. Okay, remember midpoint is that little formula where you're finding the actual middle point. Midpoint of zx, zy, and xy. Then you are asked to determine what kind of triangle it is, and also asked to describe if it's acute, obtuse, or right. Have another question that does the same thing with that. And that actually ends the lesson. There's a practice here that I found out of the book if you want to do it. What I would really do is these down here. Okay. Pythagorean theorem, distance, midpoint, slope. Here's just a quadrilateral question. Telling slope and distance again with these figures on the coordinate plane. What type of triangle is it? This is where you could use actually the names of the sides and angles. You could use Pythagorean identity if you want on this one. Here, make a square, so you can either count the squares in this case, or you would have to here find the actual distance. This one's kind of a pain. This one, parallelogram, so you'd have to do slope and parallel slopes. This one's hard. Then I've got more examples for you to find the distance of points, and then simplifying radicals, and then it summarizes the unit. Now, before I give you all the answers to all these things, I'd like you guys to try them. So this is the end of the video in terms of what's going on. I'm actually going to go back really super quick, and I'm going to do this first example because I think it's going to help you do a lot for the rest of everything, and then we'll sign off. So if I need the slope of zx, okay, I know z is the point 1, 3. X is the point 4, 5. Y is the point 5, 3. Okay, so if you're looking at ZX, I'm going to do Y2 minus Y1 over X2 minus X1. 5 minus 3 is 2, 4 minus 1 is 3, so the slope is 2/3. Or if you look at it, doesn't it go up 2 over 3? So see, sometimes you can count on these. I would. I mean, if you look at the slope from x to y, it goes down 2 over 1. It should be -2. Let's see if it works. So the slope of xy, we'll do 5. Oops, I'm sorry, wrong number. We'll do y2 minus y1, so I'll do 3 minus 5 over x2 minus x1, which is 5 minus 4. 3 minus 5 is -2, 5 minus 4 is 1, and lo and behold, it is -2. Or like I said, you can go down 2 and to the right 1. So see, you can get lucky and do slope just by counting it. So you don't have to do this formula every single time. Distance is kind of the same way. If you look at zy, I'm just going to count it. 1, 2, 3, 4. Okay, so zy was easy. Unfortunately, the other two, I have to do the distance formula. So zx is going to be x2 minus x1, so 4 minus 1, quantity squared. Notice how it's the bottom of the slope of zx. Distance formula is literally the 2 parts of slope. Watch. And now we'll do y2 minus y1, which is 5 minus 3, squared. Notice again how that's the top. The distance formula is literally the denominator squared plus the numerator squared of the slope formula. So there's a connection that you could use. Put that in your calculator. 9 and you get the square root of 13. That does not reduce. And the square root of 13, I wish I had my calculator up a little quicker. 13, where's my square root function on this I'm using a different calculator. Where is square root? I don't believe it doesn't give me a square root function on this calculator. That's insane. Yeah, it still does. Oh, wait, I got it here though. So 13 square root is 3.61. Sorry that took so long. And that does not simplify, so that one's finished. You'll want to use the numeric distance for these anyway. Zy is 4, and then xy, again, is your x2 minus x1. I can't see my points here. So 5 minus 4, notice again, it's the bottom. Plus, and then y2 minus y1 was 3 minus 5 squared. So see, it's kind of related to the slope in that respect. So when you figure this out, again, put it straight in the calculator. Get 1 squared, 2 squared is 4, plus 1, you get the root of 5. And the root of 5 should be about 2.1. Up 2.24. I was a little off. I'm not at school. I'm usually closer. So you can tell now there's the length of each side, and all 3 sides are different. So guess what? Your triangle is scalene. Okay, and we actually just answered that. It's scalene. All 3 sides are, not equal in the triangle. All right, now if you look at midpoint, the midpoint of ZX is going to be 4 plus 1 over 2 and 5 plus 3 over 2. So 4 plus 1 over 2 and 5 plus 3 over 2. I actually think 4 plus 1 and 5 plus 3, okay? So we end up with 4 plus 1 is 5 halves, and 5 plus 3 is 8 over 2, which is 4. So 1.5 comma 4 would be my midpoint of ZX. Why does that not show up on the actual picture though? ZX. 4 plus 1, 5 plus 3. Hang on a second, I don't know why this isn't working for us.